Hi everyone! Before jump into the test, let's summarize what we have learned so far. What is a set? Is a collection of objects that doesn't allow duplicate. What is a subset? Following the same rules, a set can be divided into small groups of sets. The universal set is the union of all sets in context. The empty set is a subset of every set, depending on the situation, can be counted. The numeric sets, naturals, integers, rationals, irrationals, and the real numbers are all. If two sets don't have common elements, it is said that they are disjoint each other, and the Venn diagrams represent the universal set in a box. The set operations will give a set as a result. Union, if we combine all elements. Intersection, with the elements present in all objects. Complement, everything that is in universal set, not in the given set. Difference between two sets. The first set elements without the second set elements. Duality principle. Change every universal set by an empty set, every union operation by an intersection, and vice versa. This will produce the same result. Inclusion-exclusion principle is a set algebra expression used in complex situations. The power set of a set will contain every possible set element combination. Its size is 2 raised to the number of elements. The set partitions are every possible unique combination of elements without the empty set, and there will be as much as 2 raised to the number of elements minus 1 partitions. Cardinality of a set is the number of objects inside, whether they are subsets or not. Question 1. Identify as true or false these propositions. First, A is equal to D. They don't have the same element. Second, A equals to B. Again, don't have the same element. Third, A equals to C. C contains duplicates, but still having the same. Fourth, A is not equal to D. This is true. Find a set S whose expression match with the condition. We have an inequality, and what to do when we have an inequality? Evaluate. Let's clear the x variable and see that the range is every number less or equal than minus 1, and how to express this from left to right. Again, find a set who match with the condition. We have a constant literal here. Don't panic. Remember, the first letters represent a constant number, and the last letters variables and functions. So the 8th letter is just a number that you will evaluate at the end. When we clear the x, find that all set elements must be greater than 22 times A. A way to express this is by giving a value to the constant. For A equals to 1, this is the set expression. Mark as true or false these two propositions. First, S is a subset of B. B is composed by the even numbers, and S contains 3 and 5. So this must be false. Now, how to justify? Let's see. By proving that a single element is in S but not in B, we have done. So expand both expressions and answer in any algebraic manner. Now for the second option, we see that S is contained in C, so this is also false. To the second, we prove that S is effectively a subset of C. Next question. Given this universe, identify as true or false the following cardinalities. First, the size of this resulting set is 3. Second, After these operations are done, the size is equal to the empty set cardinality, that is 0. Third, the resulting set size equals to 6. First, in any expression, always do the inner operations first, and then scale outside. We found that the size is 1, so this is false. In the second, we see that there is no common element between E, B, and D, so this will result in the empty set. Every union of a set with the empty set is the set, and then the set without its element is the empty set. This is true. Third, A and C contains the entire universe, and the common element between F and B is 5. The size of a set containing only the 5 is 1, so this is false. Next, evaluate on true or false the following propositions. Notice that not justify is required, so let's see what can be solved by a simple inspection. The first must be evaluated in detail. In the second, we see not comparable objects. Cardinality represents an integer, and asymmetrical difference represents a set. This is false. On the third proposition, we have everything on the universe not in D on the left. They are the even numbers from 1 to 9. Exactly the right side definition. So this is true. Finally, we have everything on the universe not in E set and the E set complement. This is also true. To find the first answer, let's simplify. B, D, E, and F contains the entire universe, and do the A-C intersection. At first glance, we found that this is false. In a 15-person survey with a description on their day-to-day activities, the words related to play sports were found in 7 persons. In 5 persons, the words related to go gym were found. 6 persons say related cycling words in their answers. And on the final number of persons do not say anything related to physical activities. Words related to the 3 activities were found in 2 persons. Another procedure found that 5 persons like sports and cycling, 4 persons like gym and sports, and 3 persons like cycling and gym. Having only this information, find the persons who like at least one activity. Find the undefined number of persons who don't like physical activities, and find the persons who prefer exclusively one activity. Among other ways to solve this, we found that the data fits into the inclusion-exclusion principle, and the persons who like physical activities are the union cardinality. Remember that those right here are not persons, but the times that the words related were found in the answers. Let's apply the principle with the information we have, and there are 8 persons who like at least one activity. Among 15 persons, 8 did name physical activities, so excluding them, we have 7 persons who don't. Now, to find how many people like exclusively one activity, your attention please. 5 persons like sports and cycling. Excluding the 2 persons who like everything, we have 3. 4 persons like gym and sports. Excluding those who like everything, 2. 3 persons like gym and cycling. Excluding the everything ones, 1. From 7 persons who mentioned sports, 3 like sports and cycling, 2 like gym and sports, and 2 like everything. 0 persons like exclusively sports. From 5 persons who mentioned gym, 2 like gym and sports, 1 like gym and cycling, and 2 like everything. 0 persons like exclusively gym. From 6 persons who mentioned cycling, 3 like sports and cycling, 1 like gym and cycling, and 2 like everything. 0 persons like exclusively cycling. Now, only having all the pieces, we can construct the Venn diagram. There you got the 7 persons who like sports, the 5 who like gym, and the 6 who like cycling. The persons who like everything in the center. The persons who don't like physical activities on a different set. The persons who like exclusively one respectively. And this was just a possible solution. Next question. Having the set S, list its elements and get the S cardinality. Now, this seems easy, but is not. If the set is arranged in this way, its subsets are considered its elements, so this will be the answer. Next question. Find the power set of the set S. This is pretty the fast food example, extended to 4 elements. So first, let's compute how many elements our power set will have, 2 raised to the number of elements. Then, having an idea of how many subsets we find, list every possible combination. There you got the power set of the set S. Next question. Given the set S, identify as true or false the following partitions. This is solved by a simple inspection. A partition doesn't have duplicate elements. This is a right partition. This has also duplicates, and this includes the empty set. A partition doesn't include it. Next question. Given the resulting set from a function of n, find the intersection when n equals to 3 and when equals to 5. In the same way, find the intersection between them when n equals to 4 and equals to 6. We cannot list all the natural numbers here. Just evaluate the first 10 numbers and see what we can conclude. List the first 10 elements in function of 3 and 5. What we got? The intersection will be all 15 multiples. So the intersection is a in function of 15. The same applies for the 4 and 6. 12 is multiple of both numbers. And this is all for the test. We conclude the first unit. A link with a more advanced test exercises about this unit will be available on the video description. Thank you very much for watching our video and see you on the next one.